It's Dairy Month. You probably didn't even know there was a Dairy Month. Well, there is, and it's June. Now you know. Milk is very unique in the food world. We're designed to start with it as our sole nutrition source. It has one of the most complete nutrient profiles of all foods, containing a near 1 to 1 to 1 ratio of protein to fat to carbs. If you stretch it a little bit, it's realistically closer to 2 to 3 in practice. Dairy is the only natural source of lactose, is one of the better sources of several essential nutrients, and is among the most bioavailable of those nutrients. Milk is incredibly adaptable, able to be changed subtly or not so subtly into different foods with their own set of qualities. It is considered one of the most hydrating drinks on earth, and it and its components have been foundational to nutrition for exercise. There's a lot to talk about, so let's delay no more and answer the question, what's so special about milk? I've always said protein is the most important nutrient to get right, so let's start there. Milk in most forms contains about 8 grams of protein per cup, about 250 milliliters, which is roughly 150 calories of whole milk and 85 calories of skim milk. Milk protein is divided into two types, whey and casein, with the main difference being water solubility. Whey is soluble, while casein is insoluble. Whey makes up about 20% of milk's protein, while casein is the other 80. Whey is considered the fast-acting of the two. Because it's soluble, it gets absorbed quicker, with a significant amount of it being in the bloodstream within an hour. Whey is also significantly richer in what are known as branched-chain amino acids, notably leucine, isoleucine, and valine. These are essential amino acids that are particularly important for stimulating muscle growth, minimizing muscle damage, and reducing exercise fatigue. These two factors are why it's the go-to choice for post-workout fuel. Not only in milk itself, but whey is also commonly isolated and used in supplement form. It helps that it's the thinner of the two, so it can easily find its way into shakes or smoothies. Meanwhile, casein is actually a family of proteins that are digested slower. It coagulates in the stomach due to the stomach's acids and curdles as a result, so it's harder for enzymes in the intestines to break it down. This results in a slower and steadier absorption of amino acids that typically lasts around 7 hours. This does come with the trade-off of being very satiating, so its consumption is recommended before bed for overnight digestion, or when you know you're not going to get the opportunity to eat again for a while. Beyond this though, casein does have its own unique benefits. Caseins are shown to improve immune health, lower blood pressure, and increase absorption of some nutrients, notably the minerals calcium and phosphorus, which milk is conveniently rich in. And then there's the factor of protein digestibility. I've already explained the scales that are used to measure it in a video like this just about eggs, so I'll try to keep this brief. The outdated measurement, PETACAS, used feces to judge protein quality, and its scale maxes out at a score of 1.0. As you may have guessed, milk's protein gets a score of 1.0 here. So instead, we look at the Diaz method, which measures protein digestibility in the small intestine and whose scoring can exceed 1.0. Milk score can range anywhere from about 1.1 to 1.45, depending on a variety of factors like heat treatment, whey versus casein ratios, and of course the individual consuming it. For reference, the score of eggs, chicken, and beef all hover at around 1.1, so milk protein, specifically whey, is as premier as it gets in this regard. Now, milk protein allergy does exist, wherein people with it release chemicals such as histamine in response to the presence of whey and/or casein. This can trigger a wide array of symptoms from mild digestive discomforts to extreme respiratory problems. Roughly 2 to 3% of young children have a milk allergy, but most grow out of it, so it only affects maybe 0.5% of adults. Like I said, I believe protein is the most important nutrient to get right for so many reasons, so this already makes milk pretty special. It's not just protein though, dairy's carbohydrates are also entirely unique, as milk is the only food to naturally contain the simple sugar lactose, the overwhelmingly dominant carbohydrate found in milk. It makes up roughly 5% of milk, which is about 12 grams per cup, or 250 milliliters. When it's consumed, lactose is broken down in the small intestine by an enzyme called lactase into simpler sugars, glucose and galactose. Glucose is of course used as the primary fuel source for much of the body, while galactose is taken to the liver to be converted into glucose. At the end of the day, it's just a carbohydrate, functioning very similarly to those you would see in a fruit or a potato, with one exception that lactose is actually probably most known for, that being lactose intolerance. It's simply people who lack a sufficient amount of that lactase enzyme. So the undigested lactose travels to the colon where it's fermented as bacteria feed on it. This produces gas which builds up and stresses the intestinal walls, resulting in the digestive issues we associate with lactose intolerance. The lactose also draws water into the intestines, resulting in more watery stool and diarrhea. The thing is that lactose intolerance is not all or nothing. It's a spectrum depending on how much lactase you have. An estimated 65 to 70% of the global population is lactose intolerant to some degree, and your ability to produce lactase is shown to decrease with age. But that doesn't mean that only a third of people can have milk. Severe lactose intolerance is pretty rare, and for those with just a mild intolerance, it's really up to you how much you want to consume and put up with the discomforts. I would be willing to bet that most people don't even know they have a mild intolerance. Regardless, lactose is another reason why milk is such a unique food. Nutrients don't just stop in the macro, though. I've actually found many food groups can be sorted and defined by their micronutrients. Meat is consistently rich in B vitamins and selenium. Vegetables are very often rich in vitamin K and provitamin A. Fruits are usually richer in vitamin C and potassium. Legumes rich in minerals like iron, copper, and magnesium. You get the point. Dairy has its own unique main micronutrients, and I personally think that's one of the more compelling arguments why it should be considered its own food group. Obviously, everybody knows about calcium. It's practically synonymous with milk. Calcium is one of the major minerals, meaning that your body needs it in a greater quantity. And dairy is one of the best and realistically the most accessible source of this crucial nutrient. It is most famously part of the compound that makes up all the bones in your body, but its presence is also necessary for the proper function of your muscles, nerves, and certain hormones. What I always think is strange, though, is how infrequently people mention that milk is just as rich in calcium's direct partner, phosphorus, the other major mineral in the core structural compound of bones, calcium phosphate. Dairy is one of the very few sources that is truly rich in both, which is why milk is so synonymous with bone health. But phosphorus is essential for many other bodily functions too. It is a structural component of phospholipids, which make up your cell membranes and DNA. And it's a core component of ATP, adenosine triphosphate, the body's go-to energy source. This is kind of crucial stuff that just gets swept under the rug. My guess for why dairy's phosphorus content is not as well known is because it's a mineral that's also accessible in other foods, like nuts, beans, seeds, and some seafood. But those two aren't all. Milk is also a significant source of vitamin B12, which is used in brain function, heart function, and DNA in red blood cell production. Vitamin B2, riboflavin, one of the many vitamins needed for metabolism and energy production. Vitamin A, the proper one, not the provitamin A found in plants, which is needed for vision, immune health, and skin health. Magnesium, another major mineral necessary for the health of your muscles, nerves, heart, and again your bones. Potassium, yet another major mineral needed for cellular fluid balance, nerve, and muscle function. And to round it all out, these days milk is very commonly fortified with vitamin D, whose main function is promoting absorption of calcium and phosphorus. That was a very intentional fortification choice. Several of these are among the most commonly deficient nutrients, and milk being a one-stop shop for all of them is a very unique trait. A trait you might not expect is that milk is often considered better for hydration than water itself, and even dedicated hydration drinks like sports drinks. It's believed that milk's complexity, its lactose, protein, fat, and sodium, keeps the fluid in your stomach longer than simpler drinks like water, which get absorbed and flushed out much faster. Its aforementioned electrolytes, calcium, magnesium, and potassium don't hurt either. After all, isn't that the main selling point of those dedicated hydration drinks? In order to measure hydration, I'd refer to the Beverage Hydration Index, or BHI for short. On that scale, water has a baseline score of 1.0. Full-fat milk has a score of 1.5, meaning it's approximately 50% more hydrating. And skim milk pushes all the way up to 1.58. Meanwhile, sports drinks tend to hover from around 1.1 to 1.3. So if you're really dehydrated, consider a glass of skim milk over water. And for post-exercise hydration, feel free to indulge in that chocolate milk. After all, sugar is gonna sugar. Now, aside from lactose intolerance and milk protein allergy, there are a few other concerns that have kept people from choosing to drink milk. The most urgent would probably be milk being linked with certain cancers, including prostate, breast, and ovarian. People have pointed to hormones, milk sugar, and excess calcium as potential causes, but I could not find any conclusive evidence as to why or if this is even the case. Also, I mentioned hormones, and another major concern is the IGF-1, insulin-like growth factor, in milk. It has been believed that this may contribute to skin issues like acne or certain chronic diseases like diabetes. However, a very small amount of this hormone is actually absorbed, as most of it is broken down in the stomach before it gets a chance to do so. The amount added is dwarfed by the amount that your own liver produces, so it's not shown to be an issue for most people. I should also briefly mention the processes of pasteurization and homogenization. Pasteurization is a process where the milk is heated to rid of potentially harmful bacteria. This comes with a slight vitamin loss due to their sensitivity. Homogenization is the process of breaking down milk's fat particles of varying sizes. It's done so mainly to prevent cream from rising to the top, and it's not shown to have any adverse nutritional effects. Most milks you'll commonly find have undergone these two processes. When it hasn't, it's called raw milk, which many people prefer due to nutrients, digestibility, and more beneficial bacteria, which heat treatment also destroys. But probably the most obvious reason that milk is so special is that it is, I think, culinarily the only base food that makes up an entire food group all by itself. Dairy literally gets an entire section of your grocery store, and the variety of foods from milk is vast both culinarily and nutritionally. Let's highlight a few staples that wouldn't exist without milk. Probably the most popular is cheese. Milk is acidified, curdled, heated, and then handled in a variety of ways to get the different cheeses. The cheddar you put on your burgers, the mozzarella on your pizza, the brie in your pastries, the parmesan on your pasta, the cottage cheese you have for breakfast, queso, paneer, sandwiches, salads, burritos. It's amazing how we managed to find a way to put cheese in literally everything, and all of it originates from the same source. Nutritionally, cheese is very calorically dense, often due to high fat, because it basically takes everything besides milk's water and lactose and amplifies it. The next most popular is probably yogurt, another with a fair bit of variety, often used as a base for other added ingredients. Nutritionally, major differences include less lactose, more bioavailable protein, unique vitamins, and probiotics from the denaturing and fermenting of the milk. They're also often sold much lower in fat, like Greek yogurt or Icelandic skyr. And speaking of fermenting, I always have to mention kefir, a yogurt-like drink with some of the strongest probiotic effects of all foods due to its unique bacteria. Of course, there's cream, which is what you get from non-homogenized milk, where the fat rises to the top and is collected, and butter, which takes it a step further as it's churned until the liquid is pretty much completely removed. Both of these are just overwhelmingly milk fat. And then there's stuff like ice cream and frozen yogurt, which I don't feel the need to say very much about. Dairy is one of the most universal and versatile food groups culinarily, and it all originates from the same source. Milk is so prominent that even those that can't or are unwilling to consume it have invented so many different alternatives made from plants to replicate it. Some do a pretty good job of replicating milk nutritionally, like soy milk and pea milk, while other popular plant milks do a less good job at that, like almond, coconut, oat, and rice milks. But there are so many others, some you've likely never even heard of. Hemp, cashew, peanut, hazelnut, macadamia, pistachio, walnut, flaxseed, sesame, quinoa, and even banana milk. Most of them are made by just soaking whatever it is in water, blending it, and straining out the solids. And while none of them truly recreate milk, and let's be honest, a lot of them aren't trying to, I think it speaks to the influence milk has on our society that they even try to label these products as such. And I think I've yapped enough to get my point across. Milk is a very special food. You could argue it's the only food on Earth that nature itself designed to sustain life. You may not like it or even be able to drink it, but milk's importance is not going away anytime soon. Now, if you enjoyed this video, or at the very least learned something, I encourage you to subscribe, as I'm open to doing more videos like this in the future. I also encourage you to share this video with someone who you think might find it useful or interesting. And remember that all I ask is that you do your own research and advocate for your body. You only get the one.